So I thought it would be cool to have a word in the fourth that I could use like script, where I give it a file name, and then the rest of the line it just writes whatever that is to that file, and then also executes the line. But I don't have a word like that right now, so I thought what I'd do was code it and do it recorded so that people can see how fourth coding looks and how it works. So let's start. So I'm going to write a word called script. It's going to take the file name and we want to use that to open a file. So let's have a look at the function that does that. And you see that takes the file name as a string and the file access method, which says, is it read only, write only. So I'm going to say just write only because we're just going to append to some file. I want you to open the file, and then that returns an error code if it failed. So failed to open file, and then the file itself. Now the next thing I want to do is, it says that the file is positioned to the start of the file, and I don't want that, I want to append, so I'm going to have to reposition it somehow. And here we go, we've got reposition file, which takes the position to go to and then the file. So I'm going to need the file more than once, so I'm just going to stick it on the return stack so I can reference it easily. And the position we want to give it is the end of the file, so that will be the length of the file. So can we get, file size. So we want to get file size first. And there's an error for that. Failed to get file size. And then when we've got the file size, I want to reposition the file to that location. And now the file should be repositioned. And then we want to write a line from whatever the current source looks like. So there's the source word, which gives us the source. And I don't want the whole line. So source gives us a line of source, so I don't want the whole line. I just want from where we've gotten up to after parsing the name. So I'm going to shave off some characters. And how many characters do I want to shave off? The current input position. So that should give us a string that is just the end of the line without actually moving the input position. So that's good, because when this is finished running, we want the rest of the input to execute as normal. And we want to write that to the file as a whole line with a proper line ending. So this word appears to do that, write line. It writes U characters from C addr, so the C addr U is your string to write, and followed by a line terminator, and it writes it to file ID. So I've got my string, I need my file ID, and I do write line and check for errors. And then we've got to close the file, which will do the rest of the work really. So let's remove from the return stack this time. Just take it out completely. File close, or close file. Yeah. Which just takes a file ID and gives you the error result. So close file failed to write file. Now I'm saying failed to write because when you close a file, that tends to actually do most of the writing, especially if it's a short file. So when a file fails to close, it's really because it failed to write most of the time, with caching at the OS side or in the library. And then we're done. And I'm going to make this word immediate, which just means run this word now wherever it appears, even if we're in the middle of compiling a definition. And I want that because really I want to be able to write a colon definition line by line and still use this at the beginning of those lines, so that will let me do that. So let's try this and see if it works. So if I give the file to gforth, it will run it to start with and then drop me in the environment. So let's try running script A. So write a file A 12 plus dot, and that failed, and it says error, failed to open the file. Now why would that fail? Well, let's have a look at the code. Failed to open file. So it could be that open file needs an existing file, which I thought was a possibility, but I thought let's just try without, because it doesn't exactly say in the manual what open file does. It just says open the file named. So I guess it assumes that the file exists. So there's also, if you look here, there's a create file. So I guess we need to use create file first if the file doesn't already exist. So if open file fails, we should try create file instead. So this code here, instead of aborting on failure, let's catch that and say if we've got some error status, then we want to do a write only create file. And well, we've already consumed the name off the stack, so we'll need another copy of that. And open file leaves a file on the stack regardless of whether or not it actually succeeds. So I need to drop that bad file. And then I want to check again, did it fail? This time I'll abort if it failed. Failed to open file. And I'm going to have an else condition. where I do to drop to remove the duplicated copy of the file name, which we don't need, when it does work. And then thinking about it, so let's lay this out a little bit differently. Thinking about it, so we'll send the file to the return stack in every case. The getting the file size and repositioning isn't necessary if we create the file from scratch. So let's put these in this else. So get the name of the file, get a copy of it, then try and open the file. If that doesn't work, create the file. If it does work, if we do open a file that exists, then I want you to reposition to the end of it. And so now we should have a file that's opened. Let's try this and see if it works. Script A 1 2 plus dots. Okay, so now it seems like it's created the file. So let's test that we can append to it. We'll do script A, and I'll do a definition for m/, because I like the old m/, which is sm/rem nip, I think. We'll have to test that. And this time it's failed. Failed to get file size. So let's have a look at our code. Probably got something wrong. So file size gets IO result and a double. And we were trying to get it with this rat, which should be our file that we've opened. But it's not, because that starts there at the top of the stack after we run open file. So that's what's wrong. Let's try again. Let's see if we can append. Okay, well it says it's done it. Let's see what's in there. Okay, so as you can see, it's added the 2 lines I asked it to add. And it also ran them, which is great, because that's what we want. So I'm going to say that this is copyright 2023. And I'm going to say it's MIT license, so you can use this if you want. But I'm not very happy with how it looks. I think we could refactor this and make it look a little bit prettier. So the first big glaring thing for me is that we've had to do a lot of error checking in the code. You see, every time we use one of the file functions, they can fail, and I don't even do anything that intelligent with them. So all these words that can fail, let's just have a version of that word that just runs whether or not it works and handles aborting itself. Just clear up that a little bit. So, like, for instance, we'll have create file ! Which means, like, just create the file. I don't care if it fails, then abort or something. You worry about that. So now I use create file ! There instead. And likewise, we can have the same for file size. Just get me the file size. I don't care if it fails. and reposition file, which I don't really like the name of that. So let's call that set position. Seems a bit long, reposition, for some reason. Even though set position is not that much shorter, but still. It's all about preference. And right line. And close file. So that's looking just a tiny bit neater now. And then the next thing is quite a lot of this code is just trying to open a file in essentially append mode, which is something that's it feels like it's its own job. It's something that should be quite easy. So let's have an append file word, which takes a name of the file to open, file access mode, and returns the file. So that is basically all of this code. Except we should take it off the return stack when we're done. And now that we've simplified this code just a little bit, do we even need the return stack? Let's think. We've got our string to-duped here. We have a copy of it. So if we make our file, then the result is just the file. So let's just say we'll leave the file on the stack. And then likewise here, instead of to drop, I can just do nip to remove what's under it. And then just do dupe file size, dupe set position, right? Or wrong. Well, when we get the file size, it won't be there anymore, will it? So let's just put it on the stack like we were doing. To return stack, to drop, get rid of the extra copy of the string. Then r@, file size, r@, set position, r_from. Or we can do nip, get rid of the extra copy of the string of the file name, and just do dupe. Dupe. We're going to have two copies of the file. We'll use the first one on file size, and then we use the second one with set position. In order to do that, we need to rotate it up. There we go. So now let's put that word into here. and that's doing the same thing now. So let's clean that code up a little bit. Now again, do we need to use toR? So we get our name, file name, we open up our file, and we get a file out of it. So then we're going to want 2 copies of that file, because we want to write the line and close the file. So I'll just dupe it, and then we get our string of the rest of the line, and just write that to the file. So we use rot to just bring the file up to the top of the stack, and then we close the file. Okay, that seems reasonable. Since I sort of mentioned this as this group of words just gets the rest of the line, let's just call it that. Let's just say rest of line. And it makes the code a little bit clearer. Is there another name I could give that? Yeah, probably, but that's fine. And now, does this fit on a line? Not quite. But does it have to? No, not really. Do I care? Does anyone care? Some people do, sure. But I think that what we've got here makes sense at a glance, and I think that's the main rule. Like, for instance, append file. It's over a few lines, and there's a bit of stack manipulation. But at a glance, we can see we try to open a file. If we can't open a file, we try to create a file. If we do create a file, we get the file size and set position to the file size, so set it to the end of the file. Maybe we can make that simpler. Maybe we can have a word that fast forwards the file to the end. Or that one, let's say we give it a file and it fast forwards it. Well then, let's duplicate that, get the file size, bring the other copy of the file up to the top of the stack, and set position. That makes a lot of sense as a definition. Fast forward, just get file size, set position to file size. Great. So now, this is fast forward. So append file is open a file. If you can't open a file, create a file. Otherwise, fast forward the file that you've opened. Perfect. And I've also said there's a file access mode used. That's a lie, because we are always using write only because it's appending. So I don't actually have that on the stack, so that stack comment was wrong. So just a little mistake there. And then, you know, this stack manipulation is a bit gross, but most of the reason for that is because we're trying to open a file and then create a file. We're just sort of dealing with the fallout from that. So maybe we should just break that little bit out on its own. Just say open or create. We give it a string, and it should give us a file. Well, in that case, most of this code is relevant, except the fast forwarding part. So now it fits on a line. Now, can we make this simpler somehow? So we have an extra copy of the string, We try write only open file. If that works, if that fails, then we drop the nonsense file that it returns, and then we do okay, write only create file instead. Else we remove the two things, the extra copy that's under. It's about as simple as that's going to get. But now let's substitute this into here, and we do open or create, and then just always fast forward, because there's certainly no harm in fast forwarding a new file as far as I know. And let's put this on 2 lines. I think it's a bit easier to read like that. No marks for purity. So let's see if it still works. Well, let's remove the file, make sure that creation still works. Script A12 plus. Okay, that seemed to work. And let's do one more line. And yep, it seems to work. So that's my utility to write the results of what you're typing, well, not the results, but write what you're typing to a file. So you can work in the shell and just write stuff to your file. So let's just for sake of it, it seems prudent to just write something to the end of script before. So let's say that I've been using my script utility and I like the way that it works, and I want to add something else. And well, I can start by just trying something out and then go back and add it in like this. So if I just say scripts open bracket, in this case, let's just say we're going to just get new lines. So there's the refill word, which attempts to read another line from input, and it will return true, otherwise it returns false. So refill while will stop when we can't refill. If we have source is just 2 close parentheses, I think the word for comparing strings is compare. Yep. Which returns a 0 if they are the same. So again, while the source is not just 2 close parentheses, we do source, and then is it evaluate? Yeah. Source, evaluate, repeat. I'll make that immediate too. We've got a control structure mismatch. Oh, that's fine. That's because I put 2 whiles in. I need a then to terminate one of the branches. Let's try this out. So if I do script open bracket, so it doesn't seem to be adding new lines, so I think I'll add new lines to the definition. And we also need to do an extra refill so that we don't just execute the close brackets when we finish. But otherwise it seems to be okay. And you could certainly make this more resilient and more intelligent, but this is just, you know, an example for now. So begin, refill, while source. So every time we refill, I want to do a carriage return. And when we're finished, I want it to do a refill, carriage return refill, and drop, because I don't want that extra crap. So let's try doing that again. And let's execute the function that we're executing right now. Maybe I should add an OK prompt or something. Again, we're executing the close brackets. Oh yeah, that's because I'm not doing a compare. So I've got source, close brackets, compare, while. So now if I do script, I'll run this inside it. That's the end of it. Okay, so it should have added that to the file. Let's see. Oh no, it wouldn't have done because I've not told it to. But let's just copy paste that code, which is what we're trying to avoid, is all the copy pasting. This doesn't do enough. We also want to, if we just remind ourselves, what the code looks like. I think what we're going to need is a variable to store the file in. So I'm going to call that script file. And so at the start of the script word, we are going to pass a name, open a file for appending, and save that to script file. And then we're going to have our loop. And instead of just doing this source evaluate, we're also going to do source write line. Source evaluate and print out OK with a space. So let's see if this works. Oh, no, it won't do because before we finish, we also need to close the file. So we do script file, close file. Oh, and I've just spotted another problem. When we do write line, we need to give it the file. So we'll do script file. Okay, now I've got some reason to believe that this could work. So we do script, open bracket, and we give it a file name to write to. I'm going to get it to write to script.forth. And I'm going to write what I've just been writing. And then two close brackets. So now let's look at script. And look, it's added all this stuff. And we were developing this interactively in the environment, which was sort of what I was hoping to do. And all I have to do now is just clean it up a bit according to my sensibilities. And what would have been sensible actually would have been to just also add the variable to the script. We could have done script.forth 0 value script file as well. That would have been sensible. But anyway. So now we have the value. Hopefully we can run it again and do, oh, I need a file name. Hopefully do the same thing we just did. We'll just write crap this time. 1 2 3 4 ... dots. 4 3 2 1, okay, and finish. I need to clean up that end there, but this is good enough for a demonstration. And now if we open up script again, we've got this here at the end of it. So we can develop on the fly, add stuff to the file And I'm sure that there's already something like this in G4, but I don't know. It just seemed like a cool example, so that's it from me. Please go ahead and comment if you've got any comments, and I hope you enjoyed this.